Hello everyone, this is Direwolf20 and welcome to episode 5 of Direwolf20's ComputerCraft tutorial series. Today's topic is loops. What are loops, you ask? Well, loops are a way to make certain segments of code execute more than once. It's a great way for making repetitive tasks very easy. Now, there's a couple different kinds of loops that we're going to cover in this video, and it should make things a lot easier for you if you're doing repetitive tasks, which, let's be honest, computers are perfect for. So get ready to figure out how loops work in ComputerCraft. Let's get started. Alright guys, sitting here on my standard little computer at the moment, and I'm going to edit a new program called Loop Sample. That sounds good. Or I can just go with loops. Yeah, that even sounds easier. Cool. Let's check out how loops work. Now, there's 3 different kinds of loops available in Lua that I'm going to be covering in today's episode, and 2 of them are pretty similar but have one minor difference. The first one I'm going to cover, however, is the for loop. Now, the for loop is a pretty straightforward looping mechanism, and it's perfect for going ahead and executing a certain bunch of code a certain number of times. So if you know exactly how many times you want to execute code, the for loop is perfect for you. Let's go ahead and start showing you how to make a for loop right now. So the first thing I'm going to do is just print out a line saying for loop sample. Okay, and then we're going to execute the for loop. In order to do that, we type for. And what this means is we're going to be doing the following bunch of code a certain number of times. In order to define that, we're going to have to first give it a variable name. Now, it's pretty standard coding practice to use the letter I for this. That's how I was taught. So I'm going to go with the letter I for your variable. You can really use any variable name you want. You can call it, loop interval or whatever. You can call, the variable can be whatever, right? But for now, I'm just going to call it I. And you want to put an equal sign, and then you need to put 2 or 3 things after this. First, you want to set where I is going to start. Now, for your most basic process, you're probably going to start I at the number 1. And then you want to set the end position to tell it how many times to run. In this case, I'm going to make it 10. For now, I'm just going to leave it like that. And I'll tell you what the third one is about in a moment. Okay? And like all chunks of code, we're going to have to put an end once we're done with it. So I'm just going to go ahead and write that out now. Now everything in between these parts here, the for and the end part, are going to be executed a bunch of times. So let's go ahead and print something out. That'll make it nice and easy. And what I'm going to do is print out current position. And I'm going to show you guys that the letter I, that variable that we defined, is going to go ahead and get updated every time it goes through this loop. So what's going to happen is it's going to come in here, I is going to be number 1. Okay, it's going to say keep going until we get to number 10. So I is going to be number 1, it's going to print current position, and then the number 1. And then it's going to be done. And it's going to jump up here and do I equals 2 now. And it's going to print current position as 2. And it's going to go 3, and then 4, and then 5, and it's going to keep going until I hits 10. And then once I hits 10, we're done. So let's go ahead and check this out right now to see how it works. Save, exit. And I'm going to run the loops command. Cool. For loop sample was printed out as I said, and you can see current position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So that's how your basic for loop works. And like other things like the if-then statement, etc., you can put multiple lines of code inside your for loop to do different things each time this iteration occurs. So that is your for loop. Now you don't have to start at number 1, of course. You could start at, say, number 5. And run the loops command. And you'll see that I starts at number 5, and it's going to execute this many times. Perfect. You can also, of course, make the end condition anything you want, so we could go from 5 to 20 with the letter I. Perfect. And see how quickly it is. It's running, literally, we're doing a bunch of different steps with 3 simple lines of code right here. Nice and easy. Now I did mention a third variable that you can put here, and this is the interval that you want to increase it by. So let's go back to the 1 to 10 position here, but instead of leaving this blank, I'm going to make it 2. And what this means, it's going to add 2 to I every time it goes through the loop. So what this should do, well, let's check it out. Cool. So it went through and added 2 every time. So it went 1, 3, 5, 7, 9, and then we're done. No more, because we got to the 10 position, even though we didn't execute it, because, 10 is there. If I were to make this a 0, for example, that would be a little bit clearer to see. you can see it went 0, 2, 4, 6, 8, 10, and then it stopped when it got to 10. So that is your basic for loop. And it's, like I said, perfect for knowing exactly how many times you want to run your code. Now, there's a couple different ways to do things. If you wanted to, let's say we could say, let's get rid of this 2 again, so that's going to execute a certain number of times. There's one thing you can do. If you know, for example, that under a certain circumstances you want to stop everything and get out of the loop, you can execute the break command. You just run break by itself, no parentheses or anything there. And now when I run loops, it should execute the first line. And what's happening here is it comes in, sets I equal to 0, and it's all ready to run this 10 times. And it says print current position and I, and then it hit break, so it just said, I'm stopping everything, and I'm jumping out of the loop and getting out of there. So that's the break command. Now, more often than not, you're not going to put it in there all by itself. You're probably going to want to set it under some conditional. So maybe I'll put something like if I is equal to 5, then break. There we go. It ran up to 5 and then stopped. Now, more often than not, you're not going to check to get to the 5th position here. What you'd probably want to do is just say I is equal to from 0 to 5. But maybe you're doing some more complicated things, and under certain circumstances, you want to break out of this repetitive loop bit. So, that's a good way to use the break command, and you can use that to break out of anything that you're in the middle of. Pretty cool. So we know how to do something a certain number of times, but maybe we want to keep something running until we get to the right answer. So for example, perhaps you want to have a password program set up so that it keeps asking you what the password is until you put in the correct one. So you don't want to only ask 3 times. You might want to ask, as many times as it takes until the person enters the right password. Well, that is what the while loop is for. The while loop is the perfect conditional to check a variable to find out if you should keep going. So let's check out the while loop right now. Just for simplicity's sake, I'm going to do this with numbers first, but then we'll get into writing a little simple password program like I mentioned a moment ago. So now I'm going to define a local variable called, let's call it x. Makes sense? And we'll set it equal to 0. All right. What I'm going to do is say while x is less than 10, do. And this code block that we're about to write here is going to keep going no matter what as long as x is less than 10. Okay, so keep that in mind, because if I do the following line of code like I did above, where I do print current position, let's just say print x is equal to. There we go. So what's going to happen here? Well, it's going to say x is equal to 0. So keep going until x is equal to 10. Or less than 10, that is, and it's going to print x is equal to 0, x is equal to 0, x is equal to 0. What I've defined here is what's called an infinite loop. We created a loop, but we didn't tell it any way to get out of it, and no matter what, every time I run this, it's just going to continuously run forever, and we're stuck. So we don't want to do that in this example. We want to do something like x is equal to x plus 1. And now what's going to happen, it's going to come in here and print x is equal to 0, and then it's going to add 1, and it'll come up and check. 1 is still less than 10, so I'm going to do the code again. It's going to check, all right, 2 is less than 10. I'm going to do the code again, and it'll come through. 3 is less than 10, etc., etc. So what I've pretty much done here is written a while loop that works very much like a for loop, because all I'm doing is adding 1 to a number. Pretty much, if you were going to be doing something like this, the best way would be to do a for loop, but again, this is demonstration purposes only time. Okay, so you can see here it did the same thing. X is equal to 0, and then it added 1 to it, and then it went up and checked the for loop. But notice here that we didn't actually get to the 10 position, because we're checking for less than 9 in this case. So, when we got to 10, it said, is 10 less than 10? No, so it just got right out of it. So instead of executing the line of code when we got to 10, it jumped out before it exited the code. So that's an important thing to note. Let's go ahead and write a while loop that would actually be a little bit more useful and more differentiated from a for loop. Let's write a really simple password program. I'm going to define a local variable called password, and I'm going to set it equal to just blank. Cool. And I'll say while password is not equal to DW20, do. Okay. So what this is going to do is it's going to keep checking password, and as long as it's not equal to DW20, it's going to go ahead and execute the following lines of code. And then what I'm going to have it do is do a term.write. Remember, term.write doesn't have a carriage return at the end. Enter password. Okay. And then I'm going to do the read command. And we'll just, make it read for now by itself, just so you guys can see when I type in what I'm typing. Normally you'd want to prevent that, but that's okay. But what we want to do is store that answer in password. So password is equal to read. So what this is going to do is it's going to write out enter password. Cool. And then when we're done, we'll print correct password. So what this will do is it'll pretty much be an infinite loop until you enter DW20, because what it's going to do, it's going to come in, password is equal to blank, so it's going to fail this conditional. Password is not equal to DW20, so I'm going to ask for a password and check it. And then if I enter the right one, it's going to get out and move down to the correct password line, but if I enter the wrong one, it's just going to come right back up to the while loop. Let's check it out. Cool. So the same thing happened as before. 0 through 5, 0 through 9. Now I have to enter a password. Let's type in the word password. Nope, incorrect. So what happened is it said that wasn't right. I'm going to go and make you execute that code again. Help? Test? I don't know. And it's going to keep going until I enter the right password. Good question. Well, let's put in DW20. Correct password. So, just to reiterate, what this was doing is it kept looping through this line of code until we met the conditional that we gave it up here, where password equaled DW20. Then it's done. It said, all right, I met what you told me to meet, and I jump out of the loop. So that is a while loop. Like I said before, it's going to keep executing while this set of conditional information is true. Almost like an if-then built into a for loop, if you want to think of it that way. It just checks if this is true, and if it is true, it's going to keep doing the same thing over and over again. So pretty cool. Now the next type of loop that I want to cover for you is called a repeat loop. In some programming languages it's called a do while as opposed to a while do. But in Lua it looks like it's called a repeat loop. And I'll show you what that is now. So let's do another one of these local variables. Make it equal to, I'm going to say 5. Okay. Let's look at how a while loop would handle the following conditional. While y is less than 5, and we'll even make y 6 to make it real easy for you guys. Do print y. So what this should do is, and then we'll of course put our end here. What should happen is it'll set y equal to 6, and it's going to say while y is less than 5, print y. What's going to happen here is it's going to check, is 6 less than 5? No, so it's not going to execute this y printing at all. Let's check that out. Cool. See how it did not print out the letter y. All right. Now if we do a repeat loop, let's do this. Repeat, print y, until y is less than 5. Until y is greater than 5. Okay, so what a repeat loop is going to do is, the big difference between a repeat loop and a while loop is a repeat will always execute at least once, because it's not going to check the condition that you're checking for until after it's executed this code block at least one time. So note that I'm going to repeat, and it's going to print y, and I'm going to say keep doing this until y is greater than 5. Well, y started out greater than 5, so it's still going to print it once, but then it's going to come out and say, oh yeah, y is greater than 5, let's stop. So let's try that out now. We're going to save and exit and run loops, and I'll put in my DW20 password, and it'll say y6. Cool. And the correct password there, of course, happened because I put this repeat loop before the printing of correct password. So, as always, code executes in the order that it's written here. So far, you guys haven't seen how to do that otherwise. Yet. So, all right, Dyer, we've seen a whole bunch of, samples and basics and figuring it out. Show us how to do the cool stuff. Show us how to make something neat happen with all this repeating. Because, it's a little bit not as interesting to see it on a screen. Let's see some real-world example of why you would use a loop. All right, if you guys want, let's check it out. So before I do that, I'm going to save. And what I'm going to do is paste bin put loops. So there you go. There's your paste bin segment for this video. You can go grab that. And now I'm going to go over to my mining robot, which you guys remember from before. And you remember this stairs program that I wrote. And anybody who knows programming knows that it was exceedingly wrong for me to write all this over and over and over again. Turtle dig down, turtle dig forward, turtle dig up. And then repeat. So basically we repeated these 5 commands over and over and over again. It looks like I did it 3 or 4 times. Yep, that was a lot of typing, or in the case of how I did it, a lot of copy and pasting. So let's do this with a loop. So I had this thing executing what, 4 times here? All right, I think I can clean this up a little bit. Let me clear this line out for just a moment. We're going to get rid of all this excess code and use loops to go ahead and make this a lot easier on ourselves. Oh yeah, this was a lot of code that I wrote. A lot of wasted time writing. So all I'm going to do is come here and say for I is equal to 1, 5, do. End. And then what's going to happen is this turtle is going to do these 5 steps about 5 times. Let's check it out. Go, turtle, go. Let's see what happens. Go. So there he goes. So with 5 or 6 lines of code, I've done what previously took me, 20 lines of code? Yeah, pretty much. And I could increase this if I wanted to. Hey, don't just do it 5 times. Do it, up to 10 times. Cool. And it's going to go a lot longer this time. So a repetitive task is made easier. Cool. Now, if we really wanted to be fancy, all right, let's really do it. What I'm going to do is do this. So what I've written now is a little thing so that when we run the stairs program, it's going to ask me how many times to do it. I'm going to type in a number, which will be stored in the times command. Okay? And then what's going to happen there is it's going to run the for loop that many times. So let's give it a shot. How many times would you like this to run? Once, please. Cool. Now, did I want this to be 1? There we go. Much better. And I could, of course, run it and tell it to do it twice. Cool. And, of course, if I wanted to, I could run it 4 times. Now, of course, this turtle is not smart enough to handle how to deal with this gravel, but that's not a concern. I'm going to pick this guy up and bring him back upstairs with me. So how could we solve that gravel problem? Believe it or not, we can solve it with loops. Let's go ahead and place our mining turtle down here, get him a little bit of coal to refuel, and then I'll show you guys a neat little addition that we can make to some code here to check this out. So let's edit a program called forwards. That sounds cool. All right. And what I'm going to do here is I'm going to do something similar where I can prompt it to say I'm going to say, how many blocks forward would you like to go? And then I'm going to say, blocks is equal to read. So tell us how many times to go forward. And for I is equal to 1 to blocks, do. Now, if we just wanted this guy to move forward, we could do turtle.forward. Let's give this program a try now. How many blocks? 4. 1, 2, 3, 4. Perfect. He did exactly what I wanted to. Now, of course, we have the go command, which does something very similar. Okay? But now I'm going to edit this program. And what I'm going to say is, instead of just telling him to move forward, I'm going to say, while not turtle.forward, do. Now what's going to happen here is it's going to execute the while loop, and it's going to say while the following is not true. And it's going to execute the turtle.forward command. And remember from our if-then tutorial that when turtle.forward runs, it's going to tell us whether it was successful or not by returning true or false. Now if this guy does return false, it's going to execute the following line of code, because false, with a not in front of it, becomes true. And what I'm going to do here is called turtle.dig. Okay? And what that's going to do is it's going to say, all right, I'm going to try and move forward. I failed to move forward, so I'm going to dig. And then I'm going to come right back up and try turtle.forward again. And if I fail to move forward again, I'm going to try and dig again. And I'm going to keep doing that until I get to go forward once. And as soon as I do go forward, I'm done. I'm going to move out of this while loop and continue with the rest of the for loop. So by doing this, we can prevent blocks from being in the way. So let's put a block, I don't know, in the way every now and then. And I'm going to call save and exit. And I'm going to go ahead and have this guy move forward 10 times. Notice that he's going to keep moving forward, and he'll break a block if he needs to. But he's not going to try and break a block if he doesn't have to. So now I'm going to go back 10, and we'll try this again with some gravel. So I've given this turtle a pretty high stack of gravel to deal with. Let's go ahead and give this guy the forwards command again, and I'm going to tell him just go forward 6 times. So what's going to happen is he's going to try and move forward, and he's going to fail. So he's going to dig, and then he's going to try and move forward again and fail. And he's going to keep digging until he can move forward at least once. Let's give this a shot. Oh, now I'm good. And I'm still going to move forward 6 times. Note, he did move forward 6 blocks, because even though we looped many times inside the for loop, so this for loop only ran 6 times, because he only got to move forward 6 times, even though we looped the dig command, I don't know what, almost 10 times, because of how much gravel I'd placed down there? I guess about 6. Well, sounds cool. So that's how you can use for loops to execute, saying, I want this to happen as many times as I tell it to, and then use while loops within a for loop to say, keep doing this until you succeed. So keep trying to move forward and breaking stuff if anything's in your way until you finally make it through. Good job, little turtle. You've done well to demonstrate loops. So this is Direwolf20 signing off on episode 5 of the ComputerCraft tutorial series. I hope you guys learned something about loops and how useful they can be for managing your turtles, managing your computer programs, and making your coding life a lot easier. Speaking of making your computer life easier, come back for episode 6 where I teach you guys how to use functions. Sounds like a good time, doesn't it? Oh yeah, it definitely will be. So, Direwolf20 signing off. Hope you guys enjoyed this episode, and take it easy.